All right, here we are inside of Fathom. So I've brought up one of the sample files that's provided in the program, and then it's going to look the format's very similar to yours. So again, you're just going to open your file, and once you're here, they've named it respondents. You can actually rename that if it makes a big deal to you. It doesn't really matter to a lot of people. So I'm going to double click it, and here we are again. There are 1,000 people in this particular pool of data. So I mean, obviously I'm not going to expect you to have 1,000 pieces of data. What I'm going to do is I'm going to shrink the window just like this, and now I'm going to show you how to do some of the tools that you can use to do your analysis. So for starters, I'm going to create a bunch of graphs here. So to create a graph, you just go up to the graph icon at the top, and it creates a graph. So I just left-clicked just to select the icon and clicked it in. It's an empty or blank graph, and that's fine. And I'm going to make a couple here. You can make as many as you want. And again, I'm just doing that just to show you the power here of this particular program. I do like the program, and I'll show you the why. So we go back to the first graph. You have the XY axes, and you can put whatever you want on the XY axes. So for example, I want to put age group in, so I can put it on the X axis, and here we get a nice bar graph showing my age distribution just like that. Okay, so this is a frequency graph that we talked about. It shows you how many respondents from each age group was collected. Now, I can bring province, for example, to the next one, and it'll show how many from each province were selected. And if I want, I can check the gender against it, and I hold it against the y-axis. And what we do is we get a split bar graph, which shows or distinguishes between male and female. I'm just going to make a bit of room here, so make that a little bit larger. So there we go. So this shows how many females were selected or surveyed and male, and it's broken down by province. Okay, so kind of cool. So anytime you think you have two variables that may have a correlation with each other, you can simply check it out by simply graphing them. So I could go by urban versus rural. Okay, and urban versus rural, and what else can I do? I'm not sure what this is. What's this? Played games, maybe? Who played games in the last 12 months? All right, so here are the respondents that said yes. Here are the respondents that not stated, not asked, or answered no. So there was 4 possible responses for that particular question. So we can see that a larger number of people were surveyed in the urban areas. We can do an analysis to see if urban makes a difference with rural, whether age is a factor, and so on and so forth. So I'm just going to make a couple more quick graphs here on stuff I think is related. I mean, this isn't my survey. So friend family importance in computer learning. And let's plot that against teaching. What's that? Teaching self trial and error. Let's get rid of that. So the only problem when you want to get rid of it, I think it's just easy just to delete the graph. Start with a fresh one. So let's go back to family, friend family importance and training, and then let's do frequency of email. So here we got a graph that talks about frequency in email. You know what's kind of interesting for myself is who's doing the email. So let's talk about male versus female here. So it breaks it down, and I can see how it breaks down in terms of male versus female in who has frequently emailed last month. Okay, so that's what you're going to do. You're going to look through your survey, and you're going to plot and create graphs with maybe individual variables. So for example, age is probably going to show the spread of the people that you surveyed. You may want to put it with another category, and that's fine. Now here's the really neat thing. If you want to track a particular group, so here for me, age is the obvious one. So if I want to track people who are 35 to 39, I click on the bar, and every person in that bar will turn red in all my graphs. So I can track how 35 to 39-year-olds answered every question, which allows you to go to each graph to see, is there a trend here? And when I'm looking at the trends, it doesn't really, it looks proportional, so I wouldn't say there's much of a trend there. Pretty even there. So it looks like 30 to 39-year-olds, there's no really particular trend that stands out. So let's go to an extreme here. Let's look at the 80-year-olds. And when we look at the 80-year-olds, what trends do we notice? Well, frequency of playing games. Okay, no one answered yes. So that probably makes sense, I guess, in some respects. What else? In this bottom graph here, friend, family importance, and computer learning. Some of them just weren't asked, or they thought it was very important. So you can take a look through there, and you can also go to any of the other graphs. If I want to follow who played games in the last 12 months, I hit urban. And you can actually see a bit of a surprise here. I kind of expected the 15 to 17-year-olds to be high, but the 35 to 39-year-olds in the urban area, it's pretty proportional to 15 to 17, which is kind of funny because it seems to dip there. So this is where you start making your patterns and your observations that speak to that question, that thesis that you started with. So if you asked good questions that reflected on your thesis, then you should be able to find trends. Now, when I did the 35 to 39-year-old analysis, if I said I feel that 35 to 39-year-olds play a lot of video games, and I look at this, I really can't support that. So my response to that, when I do the write-up or the analysis, it's okay to say originally the research was to look at 35 to 39-year-olds. It was anticipated that they would have a high level of playing games. However, research shows that in fact is not the case. It's okay to have part of your thesis disproved. There's nothing wrong with it in this course. And if it does happen, I mean, that's a good learning experience, and because it's going to happen in real life at some point when you have the opportunity to do something like this. So that's one way you can use the Fathom program. So that gives you some simple stuff in terms of doing the analysis. It also breaks it into numbers here. You can start doing probability calculations, simple probability calculations. So what's the probability that a 15 to 17-year-old in the urban area plays video games? Well, you'd see that it's a 42 out of 1,000 chance that you surveyed a 15 to 17-year-old, or if we're just looking at 15 to 17-year-olds, the chance is you have to expand this graph out to see it a little bit more accurately. See if I can get a quick number here. So let's say that looks like 25, let's say. So the probability that an urban person, and we need to find urban versus rural. I'd have to look that up. You want to know how many people answered urban versus rural, and you could figure out that probability by saying 25 15 to 17-year-olds said yes out of however many 15 to 17-year-olds are urban. So that gives you your simple probability, and you can get all your probabilities from that, because remember, probability is just the chance of basically how many ways a success can happen over total number of ways. Those are just finding numeric values. So that's where your numbers will come into play here. You can use this analysis. So you're able to use it for probability analysis. You're able to use it for trend analysis. And it will also let you do a little bit of regression. You can also use the graphic calculator for the regression if you feel more comfortable. So you can also use it to do some regression modeling. So if you go to the top and you hit model, you can pick a simple regression or a multiple regression. I'm going to pick a simple regression, and I want to do a comparison of two attributes. So for example, let's go with, I think this is number of computers, and what do I want to compare it against? What do we got here? So I did number of computers in house, number of people using the computer. So let's try that. So there we go. We have a regression analysis just like that. So there's 621 people in the sample. And when I go through, I see a correlation coefficient. And once you've gone through the final unit to understand what that means, an R value of 0.39 means that it's a pretty weak model. That means that there's virtually no, well, I shouldn't say no connection, but a very, very weak connection between number of computers in the house and number of people using the computer. So I would say that it's not a good model, or there's not a relationship between those two factors, even though you would think there might be. Okay, so it allows you to do simple modeling, and you can do modeling for as much as you want, especially when you're comparing a couple of things together. So keep that in mind. And what else can we use? There's also the testing. You can test correlation, analysis of variance. There's a whole bunch of stuff here, so it really depends on the data you have. And I'm not going to waste your time going through all the different types. So it depends on what you're trying to sort of come up with here, what type of data you're going to be working with. So it really depends on the analysis here, and the size and quantity of the data. So you're going to be able to play with this. If you want a particular test done or some type of graph created, we can talk about that. I just closed this, by the way. You can open it again. The nice thing with this program as well, if you have a trend, so let's say that you wanted these three graphs here, or two graphs, let's say, and the trend is the red. If you want those entered into a program, you can do that. But this is how you have to do it. So I'll show you the steps. So if I want to insert a graph into my text, into my analysis, you click on the graph you want. And if you want something highlighted, click on it. If you don't want it highlighted, just click outside the bar, all right, in here. And that will get rid of the red. So if you're doing a multiple graph comparison, highlight what you want. Make sure it's outlined in blue. Go to Edit, and you have to copy as a picture. And then you can paste it, or use Control-V, paste it right into the text. Now it's just a picture for you. And if you need two graphs to make a point, all right, so let's say you're saying there's a relationship between these two factors, make sure you put it into the report. You're not limited to one graph per analysis. If you need multiple graphs, go ahead and use multiple graphs. If you just need one graph, use the one graph. You can also bring in the correlation if you did, like I said, a bit of a test here, and you're saying, oh, I found that there is no relationship between these two. You just put it in as an image, and you can put it, please refer to figure, whatever. So Fathom opens a lot of doors for you, makes life a lot easier when you're doing comparison. You can track data, you can track specific people. So if your concern is, say, you're tracking smokers in the school, anyone who said yes to smoking, you can track and see how they answered the rest of the questions. If you're trying to track people who have had concussions from sports, you can track them through the school, and it allows you to make your conclusions that relate back to your thesis. So Fathom's a great piece of software. It has limitations. It can be frustrating, but I can help you out and get your way through that. But yeah, that's the basics. That's very, very quick, simple. It does a lot more than this. Some of you may be looking for more tools. Some of you might be saying that's more than enough. So it really depends on the depth and scope of your project as to how many of the tools you actually use with Fathom. Any questions, make sure you feel free to ask, and I can give you a hand, or meet you at lunch in the library, wherever you're working, and we can get through whatever the problem is. Good luck.